This is a tutorial on data citizenship J2G246 with R. This is especially for the benefit of the NPA Data Science GP8R46. I'm going to explain what these codes mean in a second. Just a little bit of what we're going to do today. So first of all, an overview of data citizenship, then some R, then some more R, then a little bit about the assessments, and then some time for some questions and answers. And hopefully I'll be able to get my audio fixed for then. So let's go forward. Introduction, right, a wee introduction. So welcome to the NPA Data Science Distance Learning course. Some folk from HND Networking. We've already had a bit of an introduction chit chat, well I did anyway. So yeah, so what is data science anyway? So this is something that I've been thinking about, we've been thinking about recently. And before we do that, first of all, it's very, very good to get definitions of things. Okay, so this is a definition that I learned about 10 years ago when I was at college about a computer network. So, and I think it was such a good definition that it's stuck in my head forever. And anytime anyone ever says to me, what's a computer network? I say, it's two or more devices connected together for the purposes of sharing information and resources. And if you say that straight away, that is a total indication to you that that person knows what a computer network is. So I've been trying to work on a similar definition for data science, and I think I've kind of got it. So data science is the extraction of knowledge from data to generate insights and then to take actions based on those insights. So I think data science overall, yes, it's just the extraction of knowledge from data. But it's not just that, because there has to be some purpose to that either. I mean, so we need to generate insights. And then why do we generate insights? Well, we want to take actions based on those insights. Okay, we don't just want to generate some knowledge from data, then write it down on a piece of paper, tear up the piece of paper and throw it out the window. Okay, or delete all the information once we've got that knowledge and then forget about it. So we then want to try and take actions based on these insights that we've got from this data that we've extracted this knowledge from. So hopefully, if that's the definition of a computer network, hopefully this is a pretty good definition of data science. So the NPA Data Science is a brand new qualification, and it was only released in October. It says here October 2019, but really it was more like October 2020 that any place actually delivered it. Now, what we have in the NPA Data Science is we have two mandatory units called Data Citizenship and Data Science. Now, we're teaching these as a joint pair, okay? And then with those two, we can actually choose another unit. Now, these are the options that we had to choose from, and each one has different merits. So we chose to teach it with computer programming because you need to know some programming to do some things with data. So we thought it would be sensible to teach it with computer programming. Now, another option was to teach it with a data science project, but then how can you do a data science project if you've never done any programming? And another one was to teach it with data security, because we already deliver a subject called data security, which is all about like the Data Protection Act and the Computer Misuse Act and lots of theory to do with data. Okay, so we already deliver that, but the problem is I feel like that would be maybe too much theory and not enough, too much talking and not enough action. So that's why we chose to deliver it with this top one here, computer programming. Now, when you see this HY2C46, this actually means that this is called a unit code. Okay, this is an SQA unit code. Every SQA unit has a code, and it's usually something in this format. Okay, and you can write them as separates, but I usually just write it all as one thing. So I write data citizenship as H2 J2HN46. Now, each of these is worth 1 credit, and altogether there's 3 credits in the NPA, and the NPA is at SCQF level 6. Okay, now level 6 is about the equivalent of a Scottish higher, if you've ever done a higher, or an English A-level, if you've ever done an A-level, and also there's a trick to convert it to Irish levels. You just multiply it by 8, that's Irish level 5, roughly. I don't know about like Welsh levels or anything. So the NPA Data Science is available at levels 4, 5, and 6. So we're only delivering it at level 6. The level 4 and 5, I think, is a little bit simpler, a little bit more straightforward. Okay, so data citizenship. What have we been doing in data citizenship? Data citizenship is about providing an overview of the place of data in society. Now, personally, I don't think data citizenship is a very good name. I think it should be called digital citizenship. Okay? Data citizenship? I don't. I think it's just because the other unit was called data science that they called this one data citizenship. I think digital citizenship. Now, it's a non-specialist unit. So this means that you don't have to have done data citizenship, level 4, 5 to do level 6. Okay? And it says that this could help you in the role of a citizen data scientist. So this is a new name for someone who goes and looks up data about things and does stuff with it, I suppose. So it'll also help you develop your knowledge of data science as well. Okay, so in total, it should help you gain a range of practical skills, learn about some graphs, and learn about data in society. And remember, data can be used in society for positive and for negative effects. So, it goes both ways, really, is what that's saying. And there are 3 outcomes. So these first 2 outcomes are theory-based outcomes, and we're covering these through the learner's notes and through some of the practical activities. And then interpret complex data is our evidence, our knowledge, our practical, shall we say, outcome 3. So getting into R. Right. So for those of you that haven't used R before this course, or this is your first experience of R, hopefully you've been enjoying it so far. So here is a list from December 2020 of the top programming languages, and we can see that last year, or just over a year ago, R was the 16th most popular programming language, and here it's now about the 9th. Now, I checked this again in February, and it was like the 11th or something. So it's hovering about around about the 10th kind of most popular programming language at the moment. Okay, and here is a little graph of the popularity of R recently, and you can see it's a sort of upward trend there. Okay, so what's so good about R? Easy to run commands in the console, easy to use RStudio IDE, and you can create and save R scripts. But the best thing about R, in my opinion, is the fact that it doesn't cost anything to use R. Anyone can download R, and anyone can just get started. And, we are teaching computer programming, but what I've deliberately done with this course is I have started this course and I have just said, let's just go straight into using R. And I don't want you to worry about what a variable is or anything, but let's just go straight in and start using it. And anybody, and I mean anybody with a computer, it doesn't even have to be a very good computer, can download R, can download RStudio, and there's a whole, there's a whole world there. And it, I've heard it said a few times that R is actually better than some of the expensive paid alternatives. So when you can get something that doesn't cost anything, that's built on open source software, then it's always a good idea to get behind that as opposed to something that would be very expensive, that has some kind of big license behind it. So here's some examples, and you know, I don't want to do death by PowerPoint, so some quick R examples to go into, just to refresh everyone's memory. Since you've done a few labs now, hopefully this will kind of bring together some thoughts for you. So here's my RStudio console here. Now, the first command, and I think one of the most important commands you should know, is help. All right. Now, whenever something's followed by these open and close parens, that means it's a function. Okay, and help is a built-in function. It's already there. The function just means it has some function. So if I press help and press return, okay, over here, right, is help. Okay, and this is just general help here. Now, beyond that, there's a tutorial up here too, where you can download these R tutorials and go through them. But another thing to notice as well is when I typed help there, help appeared in my history. Now I can actually click on this and I could send it over to here, over to my code. So after running a command down here, you can actually send your command. Now let's say, like, I'll delete this, right? I'll delete this. So I've got nothing on there. I could send that to the console and it'll reappear down here. So this is quite a useful little history. Now, let's say I want to clear out my history. Okay, I can just click the wee brush up there and there that goes, gone, cleared. Okay, so that's a very useful function. Another probably useful tip is if you know a function like ls, you can just put a question mark before it. And that also gives you help. So it's like question, what is ls? So if we do that, this opens up the command, the kind of built-in help for the ls function. Okay, there's the documentation there. And it says, you know, what arguments you can have, some details about it. It's even got some references here. Don't know what those references are about. I suppose it's probably overkill in terms of details. So the other good thing about R, as well as having help built in and saving the variables up there and letting us do functions, is we can have some data, okay? And R already comes with lots of data sets built in. And if we want to look at those data sets, okay, so let's go here. And if I just run the data function with no arguments, okay, not the demo frequency. Okay, there, R brings up, all of these are already built into R. So if you want to know about US arrests, if you want to know about, now, I don't mean you want to know about these things. I just mean if you want to have a look at this data and see what you can do with it for practicing, there's all this data built in. Now, some that we've looked at already are the iris data set, which is about plants, and a favorite one of mine, MT cars. Okay, just because it's simple and it's straightforward, but it's got enough numbers in it. Now, there's all sorts of things built in here. This is an interesting one that I haven't had a chance to look at yet, about diamonds, the prices of 50,000 round cut diamonds. Okay, so that might be an interesting one. Something about mammals sleep, an expanded version of mammals sleep. I've never had a chance to have a look at that. Yeah, so, and a demo frequency, I believe we used that with Word Cloud 2 in Lab 3. It's about oil. Demo frequency C is a demo data set with Chinese characters. I've never had a chance to run that as well, but I think if you were to run Word Cloud 2 with that, it might generate some Chinese characters, although I'm yet to. This is actually, I'll be honest, the first time I've ever seen that. So I learn something new when I look at this. Okay, so let's open back up my other windows. Is it? I always get mixed up if it's Control Shift or Alt Shift. Control Alt Shift. Hang on, View, Panes, Show All Panes, Control Shift 0. Control Shift 0. Ah, there we go. Okay, that's why, because I zoomed it in too much. you zoom it in too much, it gets upset. Okay, so those are just some basic commands. And like I say, if I want to access any of these are inside this data function already. So we can just do data and empty cars. All right, and this will load the empty cars data set, all right, into kind of easily accessible memory. All right, and if we run the head command, head is a common command in computing. Head just means the top of a file. We can get the top 6 items from the data set. Okay, so if we were to change that to 2, we're going to get the top 2 items. Now, this is the thing. What actually is a data set? Or another name for it would be a data frame. Okay, the way to think of it is just like a table, like the way data is set out, just like you would see in an Excel spreadsheet where you have some columns that mean something and some variables along the top. And each of those variables has a value entered. And each of those values can have a particular type. Okay, so it could be a number, for example, or it could be a character type, or it could be a what's called a floating point type, a float type. Okay, those are all acceptable types. And the type is really influenced by, influences how R would treat something. Okay, so another good trick, and this is a really good thing to get going, Control-Alt-0, Control-Shift-0, Control-Shift-0. Another good one with R is being able to create a kind of more meaningful data type in R, and the most common data type in R is a vector. So let's jump back over here. So if we wanted to calculate a percentage, we could just do 0.1 times 5. That would give us a 10%. And when R returns with this 1, this just means this is the first result here. Okay, we can go online and find packages, and we just type install.packages and put the name in there, and then we just load them with the word load. Okay, there's lots of packages available online. So we can assign variables in R with the equal sign or this special assignment operator, this little arrow character in here. And variables in R are objects, okay? And we use the term object to define data that we store with R. And all the objects that we store, okay, are kept in an area, okay, an area that we can see here, but that area is called the workspace, okay? So sometimes, okay, you might want to clear the workspace just by maybe restarting RStudio, if things start to get a little bit, it stops doing what you want to do. So we can actually load everything that's in the current workspace with this ls function. All right, so if I run ls down here, this is all my commands that I've been running in this current workspace. Okay, so there's my favorite thing there. Favorite thing to torture people with, empty cars. Okay. All right, so, functions are, if a variable is an object type, a function is a pre-built object into R. Now, we see these in all programming languages, and a function is just a little program that someone else has written to save us doing it. So for example, the help function, it's quite helpful, isn't it? So that's built in already. And we can identify a function because of these round brackets, sometimes called parens, parentheses, round brackets. I call them round brackets, I'm probably wrong. Now, the good thing about R is it allows us to nest functions. So I've done this now. I've recently been told by the accessibility team that this is totally unacceptable to do. It's not acceptable to use red text to show the difference between things because it's difficult. So if anyone has visual difficulties, this is a red word here that says my fun, and I've put 2 brackets around there, okay? Blue is good though. Everyone likes blue, apparently. So it's fine compared to red. Red and green are not good. So what this means is we can call a function and put another function inside that function, and that's just called nesting, okay? Now, when we nest functions together in R, they get evaluated from the inside out. Okay, so we can even call help on a function. Okay, so we can call help on another function and it will run the help function on that function and bring up the help for that function. Okay, so this is called nesting, nested functions, just putting functions inside other functions. Okay, variable names. Now, variables are just like boxes in memory that we can store things inside. Okay, now, if you think of the variable as like a storage box, what we can have inside this particular storage box is whatever we want. Now, R will let us call variables anything we like. So we need to be relatively sensible with what we name them. So like, you wouldn't want to call a variable install.packages. Okay, you wouldn't want to call a variable help. Now, in some languages, like JavaScript or C, you might see variables that are written like this, okay? And this is called camel case. It's like a camel's hump there, doing lowercase first letter, and then every word after that has a capital first letter. So my preference in Python and R is to use this, and this is called snake case, okay? So snake case is just lowercase underscore lowercase. Now, you can call variables whatever you want. They just have to start with a letter in R. But I find it's much easier to lay them out like this. Now, obviously, you can't put a space in there because then R is going to think it's two different things. So that's why we use the underscore. So that first word underscore second word is called snake case. Okay. That's the same thing. Okay, data types. Right. There's a built-in function that's very useful, and it's called class. And this lets us see the type of an object. Okay, so an example of that, let me just do class. Okay, and then let's see if we do help. Will that work? Okay, tells me what this is, help files with the topic. Okay, now let me just run something like x, okay, is 5. Okay, so we're going to create a box in memory called x, and we're going to put in it the number 5. So now if I run class on x, okay, it's going to tell me that x is of the numeric type, and it is because it's a 5. Now, if I run this command, okay, x being 5, and then I run class on it again, it's now a character type because we've put it into quotes there. Okay, so bit of dynamic changing there. Some other useful functions for types, you can do type of as well. str gives us the structure of an object, and head gives us the top of a data frame. Okay, so what I've done, to give just a bit of an example, I said I wasn't going to do death by PowerPoint today. So here is a data set that I had to try and make up, okay, a little table that I made up. Now, I wasn't being very imaginative when I made this up. So I had to think of 5 or 6 things and some numbers. So came up with this imaginative collection here. Now, what this is here in column A, okay, is a local country. And then in column B here, we have the population in millions to 2 decimal places. Okay, so for example, Northern Ireland has a population of 1.89 million. France has a population of 67.3 million, according to Wikipedia yesterday. So obviously these numbers will have changed probably quite a lot in the last day. So what I did was I turned this into a CSV file. Okay, so here is what the file looked like. So let's go over and have a wee look at that just now. A few people have contacted me about doing this. So here we go. This was made on March 2nd. So I put this CSV file in my R folder. okay, and my R folder is just called R. Now, if I click on the countries.csv file and I click import dataset, this brings up a useful little tool that helps me import it. Okay, now, what's wrong with this dataset? Going back here, in a normal dataset, usually the columns have names, but I've deliberately not put country and number there, just to show you how R deals with that. Okay, so let's go back to the data importer. At the moment, R has got the first row as names set. So if I take that off, okay, give it a second to reload, R is going to give these names X1 and X2. Okay, now we leave the delimiter as comma, and whatever we want to call this import, we can just put here. Now what I'm going to do is grab this text, all right, and then copy it across. Don't click import. Okay, just take that and let's do a new file in R, a new R script, and just paste that in. Now, to run these commands, as you're probably familiar with by now, you hold down Control and just press return, return, and then view countries should bring up this file in R. So there we go. There's our little mini file in here. Now, what's actually happened, okay, is this is showing you the structure of this data. Why did I make such a simple file? The reason I made such a simple file is so that we could see the whole thing. All right, we can see Scotland, Republic of Ireland, Wales, Northern Ireland, England, France. We can visualize this whole thing. If this was a huge file, this would be a lot more difficult to do. So let's have a look at some of the commands I can run on this over here. So there's our import that I just did. And if I was to run class on it, it's going to tell me that it's a data frame. All right, and I told you a data frame is, this is a data frame here, okay? We've got some columns and some variables and some rows. Now, if I run the type of function, it will tell me the type of row or the type of column for X1 and X2. So X1 is countries and X2 is population. So for example, if I run, right, countries, okay, there's countries, and then, okay, let's just, I pass that into the type of function, okay, and then I say from that, I want to use a thing called the selector, and the selector is this $sign. Okay, now it's popping up and saying, what do you want to select? Okay, let's go for X2, which is this population column. So X2, press return. It tells me that's a double. Now, a double just means a number, okay? Maybe if I do... There we go. Look, double tells me about stuff. I think I could even do, hang on, let me do double class existing to basic R types. Okay, interesting. A double is just a number, a numeric type. And then if I run that on the other type, the Scotland, Republic of Ireland, those are letters. So that would be the character data type. So data in R can be broken down into vectors. Okay, now this is very useful. A vector data type, it can just be considered to be like a collection of data. And R understands if it's a collection of data, we can do work with it. So in the examples, local countries data set that I've created with 6 lines in it, we have the these different types, and these can be considered to be vectors. So I'm going to make just a quick vector to show as an example. So let's call this my vector. Okay. Now to pass in the value, we can use this assignment operator, and then we can do create. Okay, that C actually stands for concatenate, which just means add stuff in. All right, and we're going to open up this function. Now let's say I'm going to put some numbers in here. Okay, so messed that right up at the beginning. Let's make the first number 1. I'm going to put some numbers separated by commas into this vector. Okay. So look, there's a load of numbers there. 3 of them happen to be 765 because those keys are beside each other. So let me run that now. Right. That's created a vector, a numeric vector called my vector. Now I can put my vector inside some other functions to do some things with it. So for example, okay, if I was to run min function on my vector, okay, that's going to give me the smallest number, which is 1. I think this is the largest number, 4545. So if I do max on my vector, okay, there's the largest. I can even do sort on my vector, okay, and it will sort them in order for me. Okay, I can do mean on my vector, okay, not vector, vector there, and that's the mean value of these numbers here. So R understands how to deal with and how to manage this. Okay, so now interestingly, all right, let's go back and look at this countries data set that I imported. So let's do countries, okay, and run it. Okay, so that's going to show us all of the data that we have in there. And if we do countries and we select, okay, X2, which is this column here, X2 over here, and then we pass that into the mean value. So what do you think the mean population of all these countries is? Okay, it's actually 23.16167. Okay, I think we could run sort on that and it'll sort them from lowest to highest. Okay, I think looking at the data set, Northern Ireland has the lowest. Yeah, look, there's Northern Ireland there. There's France there. Even if we run sort on the other column, treats it a little bit differently because it's character data. So you might have picked up that E, F, okay, are in alphabetical order. So it's sorted those in alphabetical order for us. Okay, so there's some operations. Another one was the str, just to show the structure of the data. So let's do str on countries. And that gives us an idea of what each column is. And this one's numeric, this one's character. Okay, so there's me running, there's me, you know, we could pass the numeric data into a vector called my vector, just like that example I showed you there. And here's x1 as a vector. Okay, this would be a character vector, and we have those 6 country names in there. Okay, so let's look at putting this into some kind of a plot. So let's do a bar plot on countries, and let's take out of countries the population column. Okay, and let's do control. I swear that popped up there. Ah, there we go. Okay, so although this isn't labeled, you can probably visualize that these are, so Scotland is the first bar at the edge here, and France is the biggest one. And that kind of, we can visualize these, how big the population of France is compared to the population of Northern Ireland and Wales down here, France and England up here, and Scotland and the Republic of Ireland here. It shows you really how different these are, just with that one plot. So I want to develop this plot, make it a bit better. So put the names underneath, and what we can do is inside the bar plot function, okay, we can put a comma, and then we can give some more arguments to the function. And the argument for names, believe it or not, is names.arg and equals, okay, and then we're going to say, what are the names? What will the names argument be? And the names argument is just going to be the other column, okay, countries, $, and then the names column, close off with a close bracket there. Okay, so let's do, unexpected symbol. Ah, there we go. So there we are. We've added a little bit of detail to that just with this one bar plot function. Then taking this to a little bit more detail, we could put my favorite color on that I found recently called Gold 1. Okay, so all we do is we take our, let's pop this up into our R script actually, because it's starting to get a wee bit long. So let's do a new, so if you want to do something that's more than one line, better to do that. Okay, take away that. And every time there's a comma, you can press return and R will indent for you. So let's do a comma, return, and put color equals Gold 1. I like Gold 1 because it just stands out. Oh, I think we need to put Gold 1 into quotes. So let's do Gold 1 in quotes. All right. Ha, look at that. Such a vivid yellow, that one. Anyway, I just found that recently. On the middle page, there's actually a list of, there's lots. There's like pale green, dark purple, all sorts. I just think that one stands out really well. So that was just a really quick run through. Hopefully that was a good refresher and maybe helped put together some kind of gaps in people's minds about I'm going to point you to some good resources, and those are the R Graph Gallery. So let me just open this in a new window here. The R Graph Gallery has lots of examples. If we click chart type, there's all these different types of charts, and so I'll pick one at random. Let's go this bar chart here, and then if we scroll down, here's all. Let's go most basic. Here's how you would do this. Okay, there's the library you load. Here's how you would plot it, and here's some more advanced methods. So that's the R Graph Gallery. Okay, there's also this tutorial, which I'd say is like a kind of good reference book, and it's got loads of programming with R. It's got loads of examples, and you can jump through, and you know, there's real like, so let's say creating functions. You click here, and there's how to define. Look, there's a Fahrenheit to Celsius conversion function, and here's all sorts of stuff here. We can look nesting functions. And the third resource is a really good video that I found on YouTube, and it's, skip this advert, it's like a 2-hour free code camp tutorial, and this professor goes through this in great detail. It's had about, look, it's had about nearly 1.5 million views, and this is, look, it's not just me that uses MT cars. Look, here's him using MT cars as well. All right, so don't just think it's me that likes it. Okay, so so there's 3 kind of really helpful tutorials that to look at. This is very intense. I wouldn't try and watch 2 hours of this. I'd try and watch maybe 10 minutes of it at a time. So, okay, looking at the assessments then. So the first R assessment, let's have a look in some detail at that just now. So Coursework 1 for the NPA Data Science and Coursework 1 for the Level 8 Data Science R course is based on outcome 3 of data citizenship. And what we've got is we've got a data file. It's in CSV format. We download it from Moodle, and we download a Word document with it, answer the questions, and upload to the Moodle. And the deadline is Thursday the 18th. I think the deadline's slightly different for the other class, but for the NPA Data Science, the distance learning course, it's 12 noon on Thursday the 18th. I think the other class is within a day of that, probably slightly earlier in the morning as well. So what's my advice on doing this? First of all, make sure you answer every question. Take your time to complete the work. If you're going to add code, add your code in a mono-spaced font. Some examples of that would be Courier, Consolas, Source Code Pro. If you just type mono-spaced font, you can find out what that is. Add your answers, and if you used any code, put the code that you used to find the answer there. And obviously don't post the answers into the group Teams chat, because then someone will probably just not do any work and just copy your answers. So certainly ask me for advice or ask on Teams if you're stuck, and I will try and point you in the right direction. So any other assessments? Yes, there's a similar coursework using Python, but we'll look at that in the Python section of the course. And there's a multiple choice test, which will be a little bit later on, but we'll prepare for that in a different way that we prepare for this. For now, I would like you to focus just on doing this R assessment. So how is it marked? The pass mark is 60%. Each submission will be graded. Marking's verified by Edinburgh College, then externally verified by the SQA, and you'll receive grades within 3 weeks of submission. And good luck. Look at this transition, by the way. So Q&A. So what I'm going to do is I'm going to stop the recording just now and see if anyone wants to ask any questions. So let me just go forward, because I think I've got a nice... When I press this, I think something impressive is going to happen. Yes. Oh, yes. There we go. Okay.